polynomial functions. Polynomial function transformations. Polynomial function transformation. So we'll just take notes for about 10-15 minutes, nothing crazy. Again, have your computer out because we're going to use the graphing calculator for some reason now. All right. Say f of x, let's say, is equal x to the 5th power plus 1, actually plus 7. Do that. Go and write that down. X to the 5th power plus 7. Okay. Let me go ahead and graph it. You don't have to graph it, just watch me graph it for now. F of x equals x to the 5th, x to the 5th plus 7. Okay. All right. That's a polynomial function because I have different terms. Polynomial is just a lot of terms added up. This case, there's only 2 terms, but sometimes polynomial functions will have a lot of terms. I only gave you x to the 5th plus 7, still a polynomial function. Now, let's go over the different kinds of transformations. So watch. Let me go to C51. Yikes, we're on credit 5 now. Let me go to the note guide. So we know all this, huh? Look at this. Let me copy and paste this to my slide here, my presentation slide. We know this stuff here. This is all familiar territory. We just had a quiz on this last Friday, and now we're just going to apply all this to polynomial functions. That's it. Okay. What I want to do though is I want to focus really quick on reflections because it can get a little tricky. Okay. Reflections over the y-axis versus reflections over the x-axis. If we want to reflect it over the y-axis, you want to make x negative before it's taken to the power. So notice right here. Notice how we made x negative to flip it over the y-axis before it's being taken to the 4th power. The action of the function is being taken to the 4th power, as opposed to, let's say, the absolute value function. The action is taking the absolute value. That's where the action's at. The action of a polynomial is taken to the exponent. So if I make the x negative before the action begins, that's why you look at there's parentheses around the x before it's taken to the 4th power. If you take it to the negative before the action of taking the 4th power begins, then it's going to be over the y-axis. But here, negative x to the 4th power, x has to be taken to the 4th power before the negative begins on the second one. Let me show you what I mean. Right here, negative x to the 4th really means negative 1 times x to the 4th. If I replace x with, let's say, 2, this is going to be negative 1 times 2 to the 4th power. Right? What has to happen first? Should I multiply the negative 1 times the 2 or take the 2 to the 4th power? What has to happen first? Let me say that again. Think of order of operations. Should I multiply the negative 1 times the 2 first, or do the 2 to the 4th power first? Which one comes first?
2 to the 4th power.
2 to the 4th power. So notice, right here, when we're reflecting over the x-axis, the action of taking the 4th power of x comes before the negative. In other words, here, like Dia said, I'll have to take 2 to the 4th power, which is 2 times 2 is 2, 4 times 2 is 8 times 2 is 16. This becomes 16 times the negative 1. Notice how the negative comes after the action of the 4th power. So, the moral of the story, what I'm trying to labor right now, is that if the x becomes negative before the action of taking to the 4th power, then it's going to be a flip over the y-axis. If the action of taking to the 4th power comes before the negative, then it's going to flip over the x-axis. Okay, I'm not sure if you guys caught that. Again, right here, negative 1. If there's no parentheses around the x and the negative, then the action of taking to the 4th power will come before multiplying by the negative 1. Therefore, it's going to be a flip over the x-axis because of order operations. The exponent has to be done before the multiplying of the negative. Let's try it. Watch me go to that function I just graphed. Welcome, Dominguez, by the way. You're taking notes. Here's the title, by the way. Polynomial function transformations. So let me go to my graphing calculator here. Watch this. If I just make x negative like this, if I just put a negative, watch what happens. Okay? Let me do that again. If I just make x negative, then what happened is we flipped it over the x-axis. Okay? We flipped it over the x-axis. But if I put the negative around the x before I take it to the 5th power, watch this. Now it's flipped over the y-axis. So there's a difference. When you take the negative around the x before it takes to the 5th power, it's over the y-axis versus without the parentheses. That's the big. That's kind of what I'm laboring right now. Let's try an example. There we go. Let's go to write example 1 here. Describe the transformation of f represented by g. Describe the transformation of f represented by g. So here's f of x equals x to the 6th power minus 7. G of x equals negative x to the 6th minus 2. I'm going to write that down. So notice how I made x negative. Okay? Notice how I made x from, so what we're going to do is we're going to describe what happened from f to g. That's all we're doing. Kind of like what we did last week. It's a polynomial function. What happened from f to g? Well, notice the negative, I made x negative without parentheses. In other words, I didn't make it like this. Okay? Which means the action of taking to the 6th power would come first. Whatever I replace x with, I'd have to do the 6th power before I multiply by -1. So what this is going to be then is going to be a reflection over, watch this now, it's going to be a reflection over the x-axis. Because the negative x, there's no parentheses around the x and the negative. If there was, it'd be over the y-axis. So this is going to be a reflection over the x-axis. So we're going to describe now. How do we get from g, how do we get to g from x? Okay, so this is going to be a reflection over x-axis. Okay. Reflection over x-axis. And then notice, we went from -7 to -2. What have to happen there? Up 5 units. In other words, to get from -7 to -2, you had to add 5. So if we're going to add 5, then definitely that's going to be a vertical shift 5 units. Because notice we're adding something here. Okay? So in other words, to get from -7 to -2, we had to add 5. So that's going to be a vertical shift. Five units up. Okay. Go ahead. We're asking ourselves, to get from -7 to -2, what had to happen? We had to add 5. So it's going to be a vertical shift 5 units up. So we can verify it. What I'm going to do is I'm going to graph this, and you're going to see how it's a reflection over the x-axis. And it's going to be a vertical shift 5 units up. So I want to encourage you using your graphing calculator to verify your answers. So let me graph f of x and g of x. Check it out. So x to the 6 minus 7 minus 7. That's 77. All right. There's x to the 6 minus 7. Now let me do g of x. I'm going to copy and paste this, but make it g of x. G of x. I'm going to put this minus 2. And look, you can see the 5 units upwards. Look at the blue graph from the red. Check it out, Rocha. From here to here, you can see it's 5 units upward. This is at -7 and it ends up being at 2. So that's 5 units upward. And watch this though. Let me make this negative. Notice how it's a reflection over the x-axis. We flipped it over the x-axis. So here's the x-axis, we flipped it this way. Look at this. Negative. So it's a reflection over the x-axis, so flipping this way instead of around the y-axis. And it's 5 units upward. So what I want you to do is use the Desmos graphing calculator to verify your answers, just to double check that you're right. You can kind of see what's going on. Okay? Let's try one more. Because you guys already know this already. This is kind of like a review lesson. It's not a big deal. Here we go. Example 2. Describe the transformation from F to G. Last example. Describe the transformation from F to G. F of x equals x to the 7th power. G of x equals x minus 3 to the 7th minus 6. Alright.
Give me a second, I'll do it.
Sure. Alright. So I'm subtracting 3 in parentheses. What does that look like on my transformations?
A horizontal translation.
That's definitely horizontal. So we want to go left to right. It's going to be in parentheses, right? We know this. Okay, we want to go to the right. As you subtract, you want to go to the left, you add. So this is going to be a right or left, Diaz?
Right.
So I'm subtracting. It's going to be a horizontal shift right 3 units. Right 3 units. And someone besides Diaz, what's going to be the minus 6? Anybody help? Let me look at my notes. So up or down, notice we're just adding numbers outside parentheses. So I know that's going to be vertical translation.
16 is down.
And a subtraction, so it's going to be 6 units down. So vertical translation. Six units down. This is really review, guys. The only thing that's new is that we're dealing with different kinds of functions. We're not dealing with absolute value or square roots. This is just polynomial functions. So it's really a review kind of lesson. It's not a big deal. All right. One last thing. We're not going to do an example. I just want you to hear me out real quick. Okay. I want to just give you a better graph. I just want to talk about this reflection business. So, watch me graph this really quick. Let's make parentheses x. Watch this function here. Okay, let's go x minus 7. Let's take all that to the 4th power. Watch this real quick. So we have a polynomial function. Okay. Watch what I do with the x. If I put a negative in front of the x, tell me what axis it reflects over. Watch this. So what did it reflect over? A negative just in front of the x. It's reflecting over what axis?
Y.
The y-axis. Notice that. Okay? Just in front of the y. But if I put it outside, if I put the negative outside, then the x would have to be taken to the 4th power before it multiplies by a negative. Watch. If I put a negative outside, it's now going to reflect over the x-axis, notice. Okay? X-axis outside. But if I just multiply the x before it's taken to the 4th power, it's going to be reflected over the y-axis. Here, outside, x will be taken to the 4th power before it's multiplied by -1, so it's going to be reflected over the x-axis. That's kind of what I was trying to labor and emphasize earlier. This right here. Here, the x has to be taken to the 4th power before being multiplied by the negative, therefore it's over the x-axis. Here, the x is being multiplied by the negative before it's taken to the 4th power, therefore it's over the y-axis. That's kind of what I'm trying to labor here. You got to know the difference. If the action takes place before the negative, it's going to be over the x-axis. If the action is taken after the negative, it's over the y-axis. Now, go ahead and graph this function on your graphing calculator. We're done with our notes for now. What I want you to do is add a slider. Okay, I want you to add a slider. Put A. So I added a slider for a horizontal shift. Go and do that for me on your screen.